Let's crack on then. So I do have the Unit 3, 4, Unit 1 and 2 book open as well if there's anything specific you wanted to have a look at. But I also got the SAC that we were going through before as well, as an option in case anyone would rather just continue where we left off. But yeah, open to any and all questions, this being a review class. So if anything does come up, feel free to let me know by message or even hop off mute. Otherwise, what are we thinking?
Hey Chris, are you just going through the thing I sent you before?
Yeah, correct. Continuing on with where we left off. Unless you want to go
Okay.
through anything else, basically.
Nah, so good.
It's all good. Cool.
Yeah, I had
Can
my
we like look at the integration application thing?
Integration applications? Yeah. Yeah, we
Yeah.
can do. Taihan, you want to say something as well?
I was just gonna say I had my first part today, so
Yeah, yeah. How'd that go?
it's pretty tough. It was like uh the whole thing was like a scenario about like some underground like pipelines,
Yep.
but it was a bit more related to functions and relations, which is a bit weird. Like they asked me like graph and stuff.
Yeah, it usually is. Did they get you to like plot a path? Like using.
Yeah, plot pass and then like
Mm.
find the min and max. It's something that really messed me up during the sack was do you know like the invalid implied multiply on the do you know when that happens on the CAS?
Invalid implied multiply.
Multiple.
Multiple.
It was like it was like it was like a D. Wait, hold on. I think I have saved on my CAS. Give me a sec,
Yeah,
and then
yeah,
I'll
easy.
explain it.
Sure. But yeah, so in terms of your applications integration, we're looking for like the integration by recognition stuff, area bound between curves. Did you have a particular focus there, or did you want to see all of it? Still with me, Nihal?
Sorry. Yeah. Can we just um can we just do from the start, like of the applications and things?
The start is in the start of this document, or the start of something else?
Uh, I don't exactly remember where it was. Um, the application stuff.
Yes, this is my document on applications of integration. It
Oh,
covers
yeah, okay.
integration by recognition, area bound between curves, average value, and a little bit about what the area under a curve might mean. Are those the sorts of things
Oh,
you're looking for?
well, I didn't go to school today, and I think they taught the application stuff.
Oh, sure. So you
That's
mean
what I
like
think.
the actual what's in the chapter? Yeah. Okay.
Yeah.
Cool. We'll have a look at that. Although I think Taihan should be relatively quick in finding what
Yeah, I'm
he's
just
got.
I'm just writing it out on a canvas and I'll take a screenshot.
Yeah. Yeah. Easy. So we'll have a look at that first, and then we can crack on. I guess it'll be 11J, your application integration, which is the average value, and a bit about like your area under a curve, what that's doing. This is the one you're talking about?
Yeah, I think so.
Yeah, cool. Okay. I guess I'll do a brief overview of what's going on here while Taihan has a browse of that. So first
I've
one,
got it ready.
oh, you got it?
So
Cool.
I'll
Let's see
send it
it.
now. Do you want me to send it now?
Yeah, yeah, go for it.
I'm just sending a screenshot in the chat. Sec.
Okay, let's have a look.
Can you see that?
I can. Yep, I'll pull this up. Time
Yeah, so
saved is
basically
that equation.
it was looking at a question. So it was looking at basically how much time is saved in production or something dependent on the depth of the drilling. So D is depth.
Yep,
And then the question was to find the depth that maxes time saved, and the domain was from 0 to 90.
0 to 90.
But then, like, yeah, what I tried doing in the CAS, which, like, first I tried obviously to define the function. So I try to define a of a of x
Yep.
as equal to that function there, and instead of d, I just used x. Um,
Okay. I think I'm not even going to finish the whole thing. I'm just going to do this and see if it gives me the issue. Okay, it doesn't. Cool. Because sometimes when you don't put the multiplication symbol in there, it might
it
cause.
happened. The thing happened when I did the max. F of
When you did the
max.
max. Okay, cool.
Yeah.
15, bracket, x take 90. Okay, that looks like what you've got there. Cool. And we're trying to maximize time saved and solving for the depth which that does. So yeah, fmax is indeed what I would be doing here. Fmax h of x, comma x. Domain was 0 to 90.
Yeah.
0 less than equal to x less than equal to 90. Maybe
Yeah, because I'm so confused what happened when I did it. Because I got to the part where you got the x equals negative infinity.
oh
but
yeah.
instead of negative infinity, it just said invalid implied multiple.
So as in you never got a negative infinity at all. You just plugged this.
Yeah. So I did what you did, but instead of getting negative infinity, I got the invalid.
So you put exactly this in the cas and it said invalid.
Yeah, I just used a of x instead of h of x.
Okay.
I'll try it again now and just see what happens.
Too
Just to
few
double check.
arguments. Yeah, usually invalid multiply has some weirdness. Oh wait, when you defined it, did you define it in the graphing tool or the calculator tool?
Calculator.
Okay.
You have to put the choosing time. Okay, Monday, Tuesday, preference time. Okay, সকাল 8টা থেকে 12টা, 12টা থেকে 4টা এরকম।
I don't know. That was really weird.
Yeah, I just put the preference, so you confirm.
Yeah.
Do you know what it means by invalid?
It's different. That's
Well,
why I
the
call
thing
you
I was looking at was maybe the multiplication symbol. So like you might have seen me try to type in
not massage, okay?
instead of comma x times x, but that didn't really do it. Maybe not putting this domain in properly. Maybe that might get it. That doesn't really do it either.
Do you think because I didn't write out the actual multiplication symbol.
Well, yeah, that's what I was trying to mess around with here with the definitions. What if I remove those multiplications? So kill that. But when you click it, it kind of, well, this one didn't do it.
Wait, could you check what happens if you try it without?
Okay.
Because I just want to make sure that because I don't know what was going on. Yeah, I got that as well. Name is not a function.
Yeah, that'll be because I removed this multiplication. So I try to get rid of this one. It just put it back in. But this one, it did not put back in. So if you put that multiplication back in there and then play it. This is why I sort of harp on about putting I'm a bit anal about putting the multiplication symbols everywhere, because sometimes like most of the time you're fine, but sometimes it does weird shit like that.
Oh man.
So it's probably, unfortunately, the misplace of a multiplication symbol, which was my first. Yeah, go ahead.
Yeah, because that was like the freest mark. I was like, I did it. I probably tried it like 5 times, and it didn't work.
Bugger.
And I didn't know what was happening.
Yeah, be super diligent with the multiplication symbols in between it, deliberately putting those in there. Between brackets, it seems to notice it, but variable directly attached to a bracket for whatever reason, it just doesn't.
Yeah.
I wonder why. Maybe it's because it's trying to, because like this notation here, variable bracket variable, maybe it's trying to think of it as a function. And so maybe it thinks x bracket x take 15 is a function. Maybe. I don't really know what else.
Yeah, because I asked other people after this. I asked some other people after the SAC, and they said they just use the extra multiplication symbol. It's just like
yeah, I think that's what it's going to be.
It's just super frustrating to be honest.
Yeah, that's annoying, but at least now you know. So it's not going to happen in the exam certainly, or in the next part to come.
Yep.
Cool. Okay, so as far as the applications of integration, first one up, average value. It is a fairly self-contained thing. So whenever you're trying to find the average of something, in fact, we even had a look at a few examples in this SAC as well as to applications of using average value. But first up, what is it? you are essentially integrating over some domain and you're dividing by the length of that domain. Doing so for a function gives you the average of that function over the domain. So if you want to, what's the average of this red line from A to B, you would integrate from A to B and then you would divide by whatever this distance is from A to B. That's what it is. Now, as far as what information you get out of it, you are getting the average of that function. So if this is a volume equation, you are getting the average volume for that time duration. If it is a rate equation, you're getting the average rate of volume. And so it really depends on what you're actually putting in there into that equation, which will determine what you're actually getting out of it. So pay close attention to what's being discussed in your actual application. If it's a temperature equation, then when you want to find average temperature, make sure it is in fact a temperature equation and not a rate of temperature equation, like this one here, dH dt. If it asks for average heat, you would first have to integrate this to a heat equation rather than a rate of heat, and then average that one. This one, however, actually doesn't even ask anything about the average value at all. But you know, if it said average rate, you would start with this one and just do the single integration and divide by the length of the interval, that bit there. If it asked instead for the average heat, first integrate this into a heat equation and then plug that thing into your average rate of, into your average value equation. So all that to say, just pay attention if you have a rate thing or if you have the actual quantity itself. Then from there, what's the question asking? Is it asking for rate? Is it asking for the equation? Because based on that, you'll either integrate to get back to the original or diff to get to the rate. You might have to do something like that. As far as when we used it, we could have used it here. Average rate of change in temperature. Now the easiest way by far, average rate of change is just a straight line connecting the points and finding the gradient of that. However, if you really wanted to, we did have the diff equation here. So you could apply the average value equation to your diff, because that gets you the average of that equation, which is a rate equation. Average value, the value was the rate. It's just a very long-winded way of getting to the same spot. But yeah, that's average value. You're simply evaluating an integral and then dividing by whatever the length is. As for what that looks like, we've got a very typical example here. What's the average value of this function over this interval? Grab your interval, make those the boundaries of your integral, solve a definite integral, and divide through by the length of the interval. So subtract the two values together. Cool so far with any of that? Any questions?
No, I'm good.
All good? Awesome. The other nuance to this is sometimes finding the integral of a function is a pain in the ass. Doable, but painful, right? Like to integrate this, you first need to know what the function is. And yes, we have enough points to create our linears, but like, let's just not do that and use geometry instead. So where possible, area under curve, the area might be sufficiently breakdownable into known shapes that have known area equations. In this case, the rectangle or the triangle. So just solve them as if they were shapes instead, and that becomes a value of the integral, because integral is area under curve. Still, just don't forget that you're dividing by the length of the domain, right? That's still a part of the formula. We're simply replacing the integral with another way of calculating area under curve. That's pretty much it for that. Do we want to practice any of that in this, or move on to the other content bit?
I think I understood. We can probably move on.
Move on? Sure. Okay. The next little bit on applications is about area under curve and what it actually tells you. We explored this a little bit on Tuesday, which was when you're doing the area under a curve, you are doing a definite integral. And what a definite integral is a two-step procedure. First you antidiff your function, and then you sub in the terminals and subtract them from each other. So in this case, you'd be doing capital F of 120 minus capital F of 35. As far as interpreting what that gives you, depends on what you started with. Now, a lot of the time they're going to start you with a rate equation, because the reason why is when you do that first step of anti-diffing, you are turning your rate into a quantity instead of the rate itself. This is dt, d time, d temperature. So by integrating this, by anti-diffing this, you get back to a time in terms of temperature equation. So rather than the rate of time with respect to temperature, you get the physical time with respect to temperature. Then, in step 2, because you're subbing in these boundaries, what that means is you now have your time in terms of temperature equation, and you're subbing in different values of temperature. This is on your capital T axis, where capital T is for temperature. So you're essentially saying time at temperature 120 minus time at temperature 35. So what this area under a curve is explaining is the time it took to get from here to here, because you have two time values that you're subtracting from each other. And so the way you interpret it is going to be depending on what function you start with, what function you head towards, which is why I always pretty much start with a diff equation, because if you start with your time equation without a rate, anti-diffing time, we don't really know what that means. It'll really depend on the question and how it's worded there. If it ever makes sense to anti-diff an actual quantity as far as the units go, anyway, which is why they'll typically do rates here. This was something I know that I never understood in school, so I just want to make sure I've explained it clearly enough here. Is there anything that needs to be clarified there? It's very much going to be on a case-by-case basis, but the gist of it is when you anti-diff as the first step of that definite integral, you're going from rate to quantity. And because you're then shoving in values into that quantity equation, what you're getting is the quantity after, the difference in quantity between your two endpoints, whether that's time, temperature, volume, area, whatever. There's a bunch of practice we can do here for it, although, where is it actually? There you go. What does this area represent? What does this area represent? Those are the things. That's where you start actually saying, okay, well, this is what it's actually talking about. This is a dV dt, so volume, rate, with respect to time. This is a population with respect to time. More specifically, it says the rate of growth. So it didn't use diff notation, but it did call it a rate of growth. So this still is a kind of like a dr dt, but just hidden a bit. Do we want to practice any of these?
Yeah. Can we do the
Yeah.
question 6?
Yeah, let's do it. Okay, rate of flow, dV dt. Firstly, find the rate of flow at t equals 0, t equals 2. Well, I mean, it already tells you rate of flow is this equation. So if you want to find the rate of flow when t equals 0 or t equals 2, what do you think we're going to be doing?
We're just subbing it in.
Yeah, just subbing in t equals 0, t equals 2. So that's going to get you 1,000 for t equals 0, and probably a bigger number for t equals 2. I'll work on defining that equation. In the meantime, question B seems alright. Find times where you have maximum rate of flow and find what the maximum flow would be. In the background I'll be defining the thing. So let's have a think about that. Okay, that's all defined.
For question B1, that's we're just finding the derivative and finding the intercepts. And looking at the behavior of the graph.
Find the derivative, look for the intercepts. Yeah, because you're saying a maximum is likely to be a turning point, and so you should diff the equation and find diff 0.
Yep.
Yeah. I will say that's normally what you do for, like, okay, rate of flow, you want to diff your flow equation, and then set it equal to 0, or F max, that sort of thing.
Oh, wait.
This is already a diff, though, is the thing.
Yeah, I just realized.
Yeah. It's already the rate of flow, so you're just gonna F max on this one instead.
Yep.
But yeah, that's pretty quick and easy. Let's do that. F max h comma x. We're probably gonna have to give a domain for this. It's probably it's already there, 0 to 15. At the very least, you would definitely. That is not the right button. This one is. At the very least, it's definitely greater than 0. So you might just say, if there wasn't one given, just x greater than 0. It does say find the times plural, so it makes a decent amount of sense why we got 2 possible answers there, 0 and 15. Does it say what t is in terms of? Number of hours after. Okay, it's not like a 6 AM sort of thing, so you just kind of give the time value as is. You can maybe say hours after it, 0 hours, 15 hours. And then yeah, find the maximum flow is only one step removed. What's the last thing to do here?
We just sub in the value.
Yeah.
No,
This is
this one's maximum. Like, wait, could you give me a second?
yeah. I think
Yeah.
the wording here is a bit weird, because they swap between saying rate of flow versus flow. I don't think they intended to change the wording.
Sorry, Chris, which question is this again?
This is question 6, and we're currently at double I.
Yep.
I don't think they meant to change between rate of flow versus just flow. They might have. Let's do it 2 ways. One where we'll start with the simple way, which is, let's just assume they meant maximum rate of flow, and then we'll take it from there with the other way, which is getting to actual flow instead of rate of flow.
Yeah.
Yeah.
So maximum rate of flow, that's going to be the derivative, the second derivative of that, of whatever the flow is.
Not
And
quite, because it's the because this is already the rate of flow as is. So
Yeah.
when you diff that again, you're getting the rate of flow. So what they're basically leading into, I think Taihan might say actually. So pause there.
No, I just wanted to clarify because I don't know if I was really getting the difference between I and double I.
Yeah. Okay.
What are the two? What's the difference between the two options?
Yeah. So this one says find time. This one says find flow. So this is a rate with respect to time. So this one is looking for t values. This one's looking for, in my opinion, dv dt values.
So double I is looking for the rate of the maximum flow, but then I is just when the flow's at the max.
Yeah, so like the reason these are indented is because this one feeds into the other, which is you first figure out when is this maximized, so you're f maxing it, and what you get out of it is your t value, your times for which there is a maximum. Then when it says find the maximum, you're essentially plugging that back in to get the maximum itself. So I can appreciate the wording on this is a bit weird. I don't think they intended to change what they meant. By saying maximum flow, they mean what's the maximum of this, like the actual max y value, or in this case the max diff value. the reason why I'm interpreting it that way rather than going through a diff procedure is because if you anti-diff this and think that you try to, instead of going from rate, you go to actual, anti-diffing this doesn't get you to flow, it gets you to volume. And so for that reason, I'm interpreting this as the same as this, right? Rate of flow. This is supposed to say rate of flow. Find the maximum rate of flow. And since this is a rate of flow equation, we're trying to figure out what's the tallest spot of it. It's like the questions that say find the time for which there is max volume and then find max volume. Yeah, you get your time for max volume and then you shove in whatever you got for your time value into your volume equation. In this case, it would mean anti-diffing to get the volume if it asks for it, but the more common one we get is that sort of thing. In fact, we might have an example here as well. Did we ever? I could have sworn we F-maxed this at some point. Let's have a look. No, not really. I mean, we F-maxed for this, but we didn't take it any further. Yeah. Point is, that's sort of my reasoning for interpreting flow as the same as rate of flow, and because I'm interpreting them the same way, they're talking about the same equation here, so there's no further need to diff again. Was that clear enough? Cool. Next up, find the area beneath the graph from t equals 0 to t equals 10, and they are specifically saying with respect to this. I'll go ahead and sketch that just so you can have a visual should you wish. In fact, it will matter because, well, maybe I won't give that away. We'll see what the graph looks like first. Zero to 15, and then auto fit from there. Okay, so it's not going to matter anyway. This is our... Is that really what it is? That's a significantly fast rate. I guess this is a cubic with 1,000 as a starting point. Anyway, that's our graph that we're working towards. Oh, it's 0 to 10, not 15. Oh no, it says sketch to 15, but integrate to 10. So, as a quick reminder, if you want to do a vertical line, you go into the relation menu there. And yep, sure enough, it's at that turning point. Again, menu 3 for graph entry edit, 2 for relation. I'll pop it back to function though. Okay, we want to find area beneath the graph between 0 and 10. What might we be doing?
Is it just a normal integration?
Yeah, exactly right. So whether this looks like a diff equation or otherwise, because it's saying area beneath this thing, you're always just integrating that thing that it's talking about. Correct. So, bare bones basic. Exactly. There's no area underneath the x-axis, so we don't have to care about any flipping of area. We just go off rip and just say that's what it is, which gives us a area of 5,000. Here's the kicker, which is what does this area represent? Like, a good way to think about this is like, what's the units of this area? That'll definitely help with the interpretation of it.
Is it just a volume?
It is volume, yeah, that's the unit for it. Now,
So
can you be a bit more specific for the scenario? It is a volume value, yeah.
these millions of liters. Okay,
Yeah.
So liters.
Yeah, you could say liters. It's 5,000 million liters is the number, is the unit for the number, yeah. What is it about, what's the significance of the t equals 0 and the t equals 10? It's like if you were to explain to me in like the real world what I'd be perceiving from this number, what would I be perceiving?
A change.
A change? Yeah.
A change in volume.
Yeah, correct. This is the change in volume. Now, any change has to be with respect to something. What is this with respect to?
In respect to time.
That's it. Time from 0 to 10. So in other words, you'd be saying 5,000 million litres were flowing from this reservoir from hour 0 to hour 10. That'd be how you'd have the most probably complete answer. You're talking about the time that it elapsed through and what the actual unit was, right? It's 5,000 million litres, which is ridiculous, and over a period of 10 hours. Cool?
Okay.
Yeah.
Okay.
So I'll be talking about, yeah, time as well as because time is part of that integral. And that, that brings it from numbers to what you would describe to a person. You'd be observing this rate of flow from the reservoir. Do we want to give question 7 a sorry, do we want to give question 7 a shot or the SAC?
I think I'm okay with this now.
You're okay with it now? Cool.
Yeah.
Because yeah, question 7 is very, very similar. So rate of growth, this is a rate of growth equation, even though it says R, it calls it rate of growth. Sketch, inverse, these are stuff you can CAS immediately. Area, and then what does that area mean? The only thing is, like, getting the area, you have to use your inverse to help you out a bit. Actually, no, maybe not, because this is a CAS. We should be able to just integrate it anyway. Yeah. Anyway, cool. Where were we? Question 3. Okay, so helpfully they have put the generic equation for that temperature thing here for us, so we don't have to scroll all the way out to the top. I found this one to be an interesting question. If the maximum acceptable operating temperature is 32 degrees, figure out the largest possible N that would achieve this. So this is a temperature equation, so temperature's on our y-axis, and it's temperature in terms of time. We want to make sure the temperature for all time is at least underneath 32 or equal to 32, and we've got to figure out what N's would achieve that, or what's the breakpoint, essentially. Not a very typical question because, or at least not a typical equation, because it's one of the first times we have two variables that we're tracking at the same time. We have N in this equation, which is controlling the coefficient of the cosine and the plus at the end. And we have T, which is controlling the horizontal aspect of it. Two things to keep track of. Only one of them is going to matter. What might we be doing here? Probably a good idea to think about, N only controls the coefficient and this term. First up, this coefficient, what does that control about the circular function? This whole thing will condense down to a single number for any given N value, and it's right at the front of the cosine. What does that control about a cosine? The answer to that would be the amplitude, right? It's the number at the very front as a multiplication on the circular function. It'll be controlling the amplitude of it. The other location for n is this plus at the very end. What is that controlling about the cosine when this all condenses down to a single number? That would be in the vertical translation spot. So if we think about our fundamentals of how circular functions work, they have some mid-level, which is given by the vertical translation, and then they have plus or minus this on top of that. So the y values are purely dictated by the vertical translation, the midpoint, and the amplitude in there. We don't really give a shit about where it's being translated to or how often it does that. We know there's a very clear cap of peak and trough that is controlled by those terms. So we don't really care about this part. We just care about, okay, here's our middle, plus this gets you peak, or maybe trough if it's a negative number, and minus this gets you the opposite thing. So we're just going to try and figure out what that looks like. So this plus that, or this minus that, both of those have to be giving us a value that's less than or equal to 32. No, you're good. Yeah, no worries. That's fine. I'm happy to walk it through. Okay, so let's do that. So we're starting with our middle. So that's going to be x plus 10,000 and over 500. That's our middle. And then plus minus, so I guess we'll just do the plus one first. Plus 4x plus 10,000 over x take 20,000. That's our amplitude value. And we're looking for a breakpoint, so I want to figure out where does this give us 32. And what do we get for that? Well, it's going to give us those numbers. N is between, so it's either 7,600-ish or 1,600-ish. So that's cool. Then we've got vertical minus this one for the breakpoint of 32. That's going to give us much neater numbers of 5,000 or 23,000. Those are our n values that are valid for that. It says find the largest possible value of n to achieve this. There's a bit of a trick here. Which of these is the largest possible value of n? I would say pay close attention to the function definition itself, because it won't be as simple as just biggest number on the CAS is the one we want. And there might be further interpretation as well. Because what we did was find breakpoints. Maybe more realistically, in fact, let me try that. It might break it, but it might not.
Do some sort of solve equation thing.
Another solve equation? How do you mean?
Okay, I can visualize it, but I'm trying to think of like how to actually do it.
Sure.
Okay. So the average value will change as we increase n, right?
Average value, yeah. So as we increase n, the midline is going to increase. Yes. So too will... The fraction's a bit harder to interpret, but yes, it should be getting overall bigger, because it's 4n on top, but 1n on bottom. So yeah, both.
Okay, so do we uh, do we do the average value function thing with the integral and the solve for n?
Kind of, but we don't need to. You could average value this equation, but what that will simplify down to will be just the vertical translation. This is unique to circular functions because circular functions are periodic, right? They are always centered about their midline. So doing the average value would just give you the vertical translation term. And if you think you're maybe setting that to a particular value, it's hard to do that because it's not asking the average to be 32, it's asking for the max to be 32 or less. So by setting the average to 32, you're actually getting a max that's bigger. So we don't really have a value to set that average value to, unless, of course, we were able to somehow figure out our amplitude, but I'm not seeing a great way. One of the easiest things we could do would just be testing all these values of n that we just got and just plot the function and see what happens. And that would be the most immediately obvious, well, the most immediately visible way of doing it. So we can set our peak of 32 as like a ceiling for it. Then we can go 4x plus 10. Oops, this is going to go bad. Can I fraction? Yes, I can. Nice. X take 20,000 times cosine pi x on 12 plus pi on 3. And oh wait, I'm using x. Whoops, that's not good. Those should be n's because I want to have a slider.
Chris.
Yeah.
I was wondering, so like the one I've sent you that we're doing now, like that was the part B from last year. So obviously I'm going to assume that our part B on Monday is going to be pretty similar. I was wondering if you still had the working out that you've done for this, because the thing that they gave us, the working out sheet they gave us is pretty bad.
Oh, sure, yeah. It's got a color to it as well. It's all yellow for some reason. It's ridiculous.
Oh, did you get that as well? Because I thought
Yeah.
that was just me.
No, it's not just you. It's just yellow for some reason.
I was so confused.
But yeah, I can. I do still have that. I just have to scroll through it, and I could export the working out for it, whatever we did, and you can also have the videos. Yeah, because the working out.
Yeah, I just wanted to. Because I'm just assuming it's going to be pretty similar, and I wasn't feeling super confident with like the combination of trig in it, just because
Sure.
trig.
No, happy to send that to you for sure. The working out might be just sort of because I was obviously doing it in the classroom environment where I was sort
that's
of talking
fine.
to
I'll
it.
be able to.
Yeah,
I'll be able to figure it out, and I'll look through the video at the same time as well. So
yeah.
Fine. Awesome. Thanks, Chris.
Yeah, no worries. Okay, so now we'll set this one up 0 to 24, and that's not how that works. 0 to 24, and then we'll auto fit whatever we got, and I guess we can just play with some n values. Like this is the. It's not a particularly sophisticated way of doing it. You're just kind of looking and seeing what happens. Where's my ceiling of 32? Not going to give that to me with auto fit. It's a bit nasty. Let's go 50. So clearly, n being 1, well and truly below. Let's test the rest of them because we're looking for breakpoints. So one of them is. These are kind of shit. I'm going to go back here. Lowest one there was 5,000. Let's test that first. So you can actually click in this and give it a value. 5,000. That looks pretty good. It peaks at 5,000 and never goes above. Cool. What else have we got? We've got 7641. I'll just kind of round that. 7641. And yes, we did find a turning point there, but the whole thing is shifted above that, not below it. So that's the wrong breakpoint. Next one up, 16,000 or 23,000. Do I need to even bother checking those? You can determine that based off of the question header, the function definition. These are n values, reminder. So if we can look at the function header in the question, anything that talks about n. Got this statement here, n can only be a natural number and is constrained between 0 and 9,000 inclusive. So for that reason, I should have also ignored that decimal, because although it is less than 9,000, it is not a natural number. Same with this decimal, but not only that, but it's bigger. 16,000, it's almost double, more than double the max that we can have. 23,000, obviously we're going to ignore that as well. So just by looking at the definition in the actual paper, we didn't have to graph this. We can clearly eliminate 3 of the 4 answers, leaving with the only possible answer of 5,000. You can do your classic multi-choice elimination approach to knock them all out. But you've also seen a way which you can actually just interpret it. You can use a slider, set your ceiling, and see what happens. Which one works, which one doesn't. Only thing you'd be a bit worried about would be, pretty sure this one might also work. 23,000 might also give you what you want. I doubt it though, it's getting quite high and it should get big. Anyway. Okay, cool. If there's no further questions about that, move on to part B, average operating temperature. So this is where I like your answer before, Nihal, which is the average operating temperature now must be below 31 degrees. This is where you could average value it, but again, because this is a circular function, we only really care about that midline there instead. But if it wasn't a circular function, yeah, absolutely, we would have to be doing our average value and setting that equal to 31, and then seeing what comes out. But because we can simplify things further, in fact, let me just grab that. Make that equal, and we only care about that term. Where does our average value get you to? 32. Oh, sorry, 31 in this case. My bad. This is basically a linear, so there's not too much that would cause us to think too hard for this one here. So in order to be below that, largest possible value of n would technically be 1 less than this, because it says below, not below or including. Right, this in part A it had a less than or equal to sign. This one said below, which the answer key doesn't even give the it gives the inequality, which it should be giving 5499, because n is constrained by natural numbers, and it should be a number because it's asking for a number. Fair enough there? Yes.
Yep.
Yeah, cool. Alright, part C. N such that the difference between max and min is less than 6.4 degrees. Okay, so definitely still relying on the fact this is a circular function will help a lot in simplifying this, because otherwise I guess we'd be doing an f max and f min and then subtracting. Yeah, so you do your f max and f min to get the max and min of the functions in terms of n. Then you would have to find the absolute difference of them, so you strip any positives or negative, or just make them both positive, and then subtract, and then set whatever that is equal to 6.4, and that gets you your breakpoint. We're not going to do that because we don't need to. There is a much better way because we have understanding of circular functions. Max and min, we talked about this earlier. How is that being set? It's being set by the vertical translation term and the amplitude. Right? Plus or minus is going to get the max and min. So we already kind of have those equations set up. Now the challenge is going to be, how do we put them together? Okay, so it's going to be max. Which one's max, which one's min? Next we can put absolute value signs on them and then just not worry about it at all. Yeah, let's do that. So I'm going to pull out the notes actually just so I can write out this, because it's going to get a bit more confusing to try and do it all in line on the CAS and solve at the same time. So we have max, which is the amplitude plus the midline. Yeah, amplitude. And we have the min, which is the midline minus the amplitude. So with that in mind, okay, I need to get the max equation, the min equation, and do the absolute. So max, let's just call it n plus that, plus the 4n n thing. And min is the opposite. It is the n minus the 4n over n. And then you just do max minus min. But because I don't want to think too hard about which of these is positive and which of these is negative, I'm going to put it in the absolute value signs, which the CAS can do. So let's do it that way. We'll define two separate terms. One is max, one is min. Let's just go O of x for the max, or what we're calling the max. That can be that one. So if we're going to say max is plus, then I should put a plus there. And then the other one, p, can be the min, which is also this. Control V, where is it? There we go. Which is that. Then we are doing the CAS solve of max take min, and to be safe, so we don't get any negatives in there, we're going to go ahead and do the absolute, which I believe is just ABS. Yeah, it's right there. Which,
Wait, Chris, what was the shortcut that you got to find the absolute value?
so the book button that's next to your structure, the piecewise looking thing, this is a list of all the functions in the CAS. And all I did was click A to get to the A functions.
Cool.
You can type this out, by the way, just ABS, and it works fine.
Also, one more thing, just before I forget.
Yeah.
I was just curious. I don't know if I asked you this before, but about UDFs.
Yeah, so my stance on UDFs was around, I've typically not given, like I had a debate whether or not I was going to include UDFs in this, and the stance on that was I would prefer that people understood the fundamentals deeper and practiced those, because if you're reliant on UDFs, yes, it is faster, absolutely, but there's two scenarios. One is you're not doing so well at methods and you're fully reliant on UDFs and you don't really know how to interpret from there, or you're good at methods and you're using UDFs to speed things along, but you're only saving like a minute, like not that long. You're not saving too much by doing UDFs.
Yeah.
So I see it more as a crutch. By all means, use them. But I would say in your practice, focus the majority of your practice on the fundamentals of actually getting the right things done, and then like the remaining 10% of study, you can practice your UDFs if you find them.
Yeah.
I just haven't found any that I like.
Because I saw someone like from the, because they're like some big tutoring company or something, like they pull out like some kind of UDF that has like, they input the graph and it gives them the intercept and like 6 different points of information from one UDF.
Yeah, I remember there was one where it's like you put in a function, it'll tell you where's the maxes, where's the mins, where's the intercepts.
Yeah, that's the one. Yeah, that's the one.
Yeah, and you can have it. It's fine. It's like it does the job. Um, but yeah, I just found it doesn't like if you've got a CAS anyway, it doesn't take that much longer to just do menu 3.1 solve for your intercepts,
Yeah,
and so on.
yeah,
Feel free to use it, but
yeah,
just know that I don't really have like I'm pretty sure you've got like there's a thing as a plug in the top of the CAS where you can install things. I think it
yeah.
saves to I don't even know where it saves. So you're gonna have to be on your own a little bit for the installation of that. But I'm pretty sure once it's ready it'll be
Yeah,
in
no,
the book.
I put one in today, but I didn't even use it.
Yeah, sick.
Like I just got someone to do it for me, but
Oh yeah, cool. Yeah.
yeah, I feel like it doesn't help
Yeah, it doesn't.
that
I mean,
much.
yeah, because like you either know to use it or you don't. Like if you just use a UDF just to see, just
Yeah,
to throw shit at the wall, like yes, the information will be there, but you still got to
yeah.
understand how you're using it. It is
Yeah, it was the
faster,
same because
yes.
like even like with the band reference, your band reference is really good by the way.
Oh, that
But
is good. Okay.
like
তোর বাবার বানাই
like it didn't help me in the sack, like if that makes sense.
Yeah, that's
Like
more or less. It's like a peace
yeah,
of mind thing.
yeah,
Yeah, it's like a. Ideally, you make it your own, so you know where things are. That'll
yeah.
also help. But again,
Oh,
like
do
I
you
said
want?
this plenty of times, you pull it up like once in the entire tech
Yeah.
active.
Actually, I was wondering, do you have because you send me the band reference for calc,
Yeah.
and your one about function relations, does that include for trig?
Yeah, so it's everything that I consider functions relations, which is just this is the
Okay.
function type, this is the graph of it. Yeah, so trig is
Yeah.
included.
Because what I'll probably do is I think I'll just because I've already printed out the calc bound rec, but I'm thinking of just printing out the entire function relations on just putting them both together.
Yeah, just stacking them. They got unique contents pages as well. So and they're
Yeah.
page numbered, I believe. Yeah.
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 Do you reckon I should just put in the prob one as well now, just for the end of the day?
Yeah, why not? Okay, well if you like them, then I'll put them on the school. I just thought they looked
Yeah.
a bit ratty, so I just
Yeah.
haven't.
I
put
mean,
'em
if
in
you
there.
do make like an updated version or anything like that,
Yeah.
just I guess let me know.
Oh, for sure.
Yeah.
But yeah, okay. If you're happy with where they are now, at the very least, I'll make it available to everyone on the school. I just thought they looked a bit shit. Probability I think was alright, but the
Yeah.
other ones were.
No, it's just like calc one was like I printed out the bound reference, and then my friends were like, "What are you holding?" It was massive.
Yeah, it's a stack, and
Yeah.
it had every exam question that I could spot with that were unique, that had its own way of going about it.
Yeah. Yeah.
But cool. I'll make a note to put those in. Where am I going to put them? I guess maybe they can be in the modules. So like the functions relations module, you have the functions relations bound reference. The calculus one, you have the calculus bound reference.
Yep.
Oh my god.
Yeah, that's where they'll go, I think.
Awesome. Thanks, Chris.
Cool. Okay, so we have our time, but I'll just finish this one up quickly. So where were we? It's the absolute of the difference, the max and the min, and we wanted that difference to be less than 6.4. So let's get the breakpoint first. 6.4, and the x's in this case are n's already. So let's do comma x. That's going to get us a negative number and a positive number. Given that n is natural and between 0 and 9,000, I'm pretty happy to say that n is going to be 7,500, which you can validate should you wish, which would just be going on the graphing tool and then just seeing, oh yeah, the max is this, the min is that, and then go from there. You can even f max and f min again. I'm noticing they did it a bit differently in the answers. They just did the negative of the amplitude and made it equal to 3.2. The difference between them. Oh yeah, that's so much easier because it's bidirectional. Yeah, so if the difference between top and bottom is supposed to be 6.4 and the amplitude is what forces the difference, then just half the difference and then just set the amplitude equal to 3.2. Yeah, that's way easier than what I did. Oh, now you got two ways of doing it: the special way and the better way. Yeah, there you go. Make have a more sophisticated understanding of the circular functions. There we go. Hopefully that method made sense. If not, just yeah, half the difference is the amplitude. So do that. Cool. Any further questions? Happy to answer them. Otherwise, I'll pop those bound references up here now, and we'll ask for forgiveness in advance for the look of them. They're all right, but
No, honestly, they're fine.
they're fine. Yeah, cool.
Yeah, like it's just the hard part is like the table of contents. As in like sorry, the hard part is like some parts, like it just felt like a bit of a list, but it makes sense like if you're doing the question for that specific topic and you will have already looked at the table of contents. So
Yeah, like the idea of the contents table there was to say like, okay, here's the dominant topic for it, and then here's the kinds of questions that get asked for that dominant topic.
yeah.
And like some of the headings are a bit like I tried my best to explain what are the key variables in it. Like if you have n, you have x, you have y, do this, and so on.
Yeah. Other thing is, yeah, we've been told we're not going to have I'm not going to have integration on the second part at all, and like they just
Okay.
decided not to have it today either. So
That's
that's why I'm probably going to have. Yeah, apparently they're going to keep integration for a separate SAC.
Okay, so they are. Okay, so you've only just done the first calculus SAC.
Yeah.
Yeah,
Like,
the
no,
first.
What I'm
the first,
doing, it's one SAC, but it's just split into two parts.
Yeah, yeah. So as in, this is SAC, which is functions relations up to diff.
Yeah.
Yeah, that's pretty common. And then the next one up is a calculus that includes mostly integration. And then lastly they do a probability thing.
Yeah.
That's very normal. Yeah, that's fine.
Yeah.
I just didn't realize you were in the you were still in the first version of it, the first part.
But for the final exam, is it mostly like what we've covered? Is that like basically just most of the content?
Yeah, we're only missing the probability stuff.
Yeah.
Um,
That's pretty minor, right?
it's. I don't think I'd call it minor necessarily. We can I'll pull up a tech free and a tech active, and we'll just do a quick squiz at what's going on.
Yeah, sure.
So question 1 in tech free is always diff or anti-diff, right? So find diff, find gradient tangent, cool. This is just some functions. Oh no, this is actually still anti-diff. Function stuff, probability, function stuff, and a bit of diff, probability, function stuff, bit of diff, probability. So it's like every other, it's like kind of like it's bouncing back and forth between function, diff, probability. That's kind of what seems to be going on there.
Yeah, so it's basically just like the three parts, just functions, relations, calc, diff.
Yeah.
Calc and prob.
Yeah, and in tech active what you get is you get a full, because the questions are so much longer, what you find is probability is its own full question, and they'll toggle between different types. This will be a continuous probability, then it transitions into some sort of discrete here, or maybe not. I don't know, I'm just kind of quickly looking at it. Then you go into different kind of probability again, and that'll be a big stack of things there. Does it have it? Yeah, 14 marks. And that'll be the only, that'll be the only spot in the extended response. So what's that? Like 25%, 30% of the section B. So probability is still pretty sizable. Cool.
Yep. Yeah, that makes sense.
Awesome. Anything further?
Wait, for the method exam, can you take in a CAS and a scientific?
Yeah. You can
Yeah.
bring in a CAS scientific,
It's a
but
bit weird.
yeah, I don't see why you'd bother with the scientific if you got the CAS. Maybe as a backup in case your CAS dies. God forbid.
Yeah.
Oh, excuse me. But yeah, tech free, you got none of that. No tech, no notes, no phones.
Oh, no bound reference for.
No, definitely no bound reference. Never has been for tech free.
Yeah, because that's why I was wondering, like, because a lot of your bound reference stuff was for tech
Yeah.
free.
Oh, okay.
Like some of
Um,
it, like you have for like when I was going through, it's like you have the method for tech free and for tech active.
yeah. It's a good point. Yeah, you only get a bound reference for tech active, so I guess technically it doesn't need to be there, but I kind of just, the way I made that was I went through all my notes as a snapshot at
Yeah,
that
that's fair.
time and then just copied out
Yeah,
all that was in there.
yeah. I think it's a pretty good revision tool, but I'm just thinking like I guess if you're able to like develop a resource for end of year,
For end of year.
like I guess
Yeah, as a
yeah,
big bound reference for the end of year. Yeah, I can try that, but I do still think it'll be better if you guys make your own so you know what's in there. I'll
yeah,
make one
yeah.
there anyway
That's
because
fair.
people are there's gonna be like a last minute thing and people are gonna be like
Yeah.
panicking for it.
No, I think
Yeah.
it's good to have like a model, and then you can kind of like because for my bound reference, I'm probably gonna like screenshot random stuff. Probably
Mm.
take a couple of your pages. It will be kind of like a Frankenstein kind of
Yeah,
bound
I mean
reference of
that's
random stuff.
it's like a little arts and crafts project. You just I want this one and this one and this one. That's kind of like how I made mine. My school had a bunch of little mini bound references for each term, and I just literally stripped them all of their spiral bound, went to Officeworks, bound the whole thing together, and then at the back was handwritten sheets of like my own working on key questions that I wanted to include. It was all good fun, and then I opened it up once, ever.
Still a good revision, but
Yeah, it's part of the revision process, so that's fine.
awesome.
Cool.
Cool.
I'll put those in the relevant modules, and I will. Yeah, I'll see if I can do something about putting them all together. That'll be interesting. Each one of them is already quite thick.
Yeah. But I guess obviously like it would just be for the tech active relevance stuff.
Yeah, that's
So it
true.
would be shorter.
Yeah, that is true. Cool.
Yeah.
I'll
Awesome.
well, I've got plenty of time to do it, I guess. Still got months, so let's see how we go.
I'm sure it'll fly by. Awesome. Thanks, Chris.
Usually does. Thank you.
Have a good night. Bye.
You too. All right. Well, I appreciate you coming, even though you had your headache. That's yeah.
Yeah. I don't think I. Yeah, I think I need to rewatch the class thing again.
Yeah.
Speaking of that, you release it at the end of the week, right?
Yeah, this one seems like it's got a bit of urgency, so I'll pop this up as soon as I can. Yeah,
Okay.
I'll pop the sequence up now. Yeah, that's fine. I'm actually house sitting for my parents right now, and their Wi-Fi is not the best, so it might take literally the whole night to upload. So yeah, by tomorrow morning it should be up here.
Okay. Yeah. Thanks.
Yeah, no worries. Thanks for coming.
Have a good day.
You too.
See you.
Take care.